We're never late for me. Hey!
Hey, yes. Welcome to
morning.
Practice Biology, day 31.
Crazy.
Yeah. I got some more cell cycle notes turned in yesterday. So apparently going over it was good. Apparently some people, even with going over it, still haven't figured out how to do it, but whatever. So we're going to try and make this pretty quick today. We do have a little thing that we'd like you to do afterwards. So we're going to try and make it pretty quick so we can explain it to you and you can get out and do that and be done for the day with biology. Attendance form is in the thing. So Darius, first like. Darius, first here. Alexia tells Darius to be quiet. Darius laughs out loud. Alexia, Darius, Alexia, Elijah Minton in the house. Dominic, Emily, Anna, or Annie, Anna. Darius again. Maya, good morning, home base. Audrey Wade. Cameron. Mrs. Smith told me how to say your name right. Alan, Abby, Jeffy Jeff, Carissa. So is it Alexios?
Alex.
Okay. Michaela, Moya.
Elizabeth. Woo!
Emma, the lurker. Shay, this is hard. Gladys, Zulika, Xavier,
Mark.
Diana, hola. Jake, Shay, Haley Funk.
Connor.
Oh, there's some funk in the house. Should I grab my guitar? Eli, Andres, Cody, Mr. Hatfield, William. Who else? Who did I miss? Miss anybody?
I don't think so.
Should I just say Dominic? Because every time we don't say Dominic, he yells at us for missing.
Dom's here.
Where's Dom?
Did you say Zuli? Zuli's here.
Let's see Dom. All right. I think we got just about everybody that said hi so far. To you lurkers out there that never say hi to us in the morning, first of all, shame on you. You should be ashamed of yourself because we like to see your names pop up. And I haven't seen like Donald Trump, Big Boy, or none of our presidential candidates have been in recently. Wondering about that. But if you're lurking, we're happy that you're here. We would love for you to say hi. But yeah. So, Mrs. Smith, we've been talking about the cell cycle.
Woo!
We talked about interphase and how it just hangs out there and grows and develops and makes replicates and all that. Today, you're going to tell us how we get from like one cell to two.
Right. So we're going to focus on that section of where we're talking about mitosis. And so I thought I'd start with the same little kind of slide that I had on there before. Remember when we talked about the whole cell cycle, it's interphase, prophase, metaphase, anaphase, telophase, and then cytokinesis. Mitosis is that just PMAT portion. Okay, and so as we kind of talk through, let's talk about prophase first. So prophase is like the first phase of mitosis. And what has happened in between interphase and prophase is the fact that the chromosomes have kind of been wound together, okay? And so they're tightly coiled, easier to separate. The nuclear membrane disappears. Remember, we talked about that bag that all the chromatin was in, and Eli said, take it away. So here we're starting to get rid of that nuclear membrane. And then the spindle fibers start to form, okay? And the centrioles start to migrate to the poles, to opposite sides of the cell. And so Mr. Suter always loves this part where it talks about the nucleolus disappears. And he loves to say, how can something disappear if it never really existed? So I'm going to let him talk about that at some point. Okay, after prophase, it goes to metaphase. And you'll notice that there's two pictures here. And that's because it's not like it goes from being inside the nucleus to all of a sudden lining up. It has to be that the spindle fibers attach to the chromosomes and then kind of push them and pull them to get to the center. Okay, and so the center is called the equator. If you think about meta or middle, it's going to the middle of the cell. This is probably the easiest cell to recognize because they're all lined up in the center on this equator, on the center line. The next phase is anaphase. And if you remember that ana or an in front of something, aerobic, anaerobic. If we talk about anaerobic, we're talking about not. So if you think about that, this is the not or the opposite phase where they're moving to opposite sides or opposite poles. And so the centrioles start, it's like a fishing line. Okay, so it throws out a fishing line, attaches to the chromosomes, aka the fish, and starts reeling it in. Okay, and as it starts to reel it in, they pull to opposite sides. And as it starts to pull to opposite sides, what happens is the cell starts to pinch a little bit in the center. And so as you get to this telophase portion, there's this pinching that happens in the center. It's called a cleavage furrow. Okay, and that's going to continue on. That's really the start of cytokinesis, because cytokinesis is where the cells separate. In mitosis, we talk about the genetic information separating. So in telophase, this is the end of the mitotic phase where the chromosomes start to unwind again back into chromatin. We start to see that nuclear membrane reform around the those chromosomes. And so that's starting to form again. The spindles, release and start to disappear. And the centrioles actually duplicate here in preparation for the next mitotic phase. So they duplicate at the very, very end of mitosis. And then finally, we get to this section that is part of cell division, but not part of mitosis, which is cytokinesis. Okay, and remember that cytokinesis is actually the division of the cytoplasm. And here, everything is divided. So the cytoplasm, all the organelles, and we're left with two identically or genetically identical cells. And then the cells return to interphase. And so that's just kind of a brief overview. Here's kind of a picture of everything together on one slide where you're looking at the G2 phase of interphase, okay, and then into prophase, and then that kind of movement in between prophase and metaphase is sometimes called early metaphase. It can also be called pro-metaphase. And then from there, after they're on that equatorial line, starting to separate, okay, separating further, and then actually separating cells through cytokinesis. And so this is just a little different animation that goes through. We showed you one yesterday or 2 days ago. And so here's another one just going over quickly that process. And lastly, what I wanted to just quick do is show you some actual pictures of cells underneath the microscope. And the reason I like to do this is that in every picture that you see that we draw or that you make, it's like there's 2 or 3 chromosomes. Remember that you have 46 chromosomes. And so as we're going through this, it's going to look a lot different. So when you're looking at something, you're like, oh man, is that quite metaphase? If they're lined up like it is in the second picture on the left, so this one down here, that's metaphase. They're all in the center there. Okay. When you can barely see the stuff in the center, in the nucleus, that's when it's chromatin. So that's like telophase entering into interphase. Okay. So as you're going through, that's kind of some of the different parts there and the different cells and going from prophase, metaphase, anaphase into telophase and cytokinesis.
Awesome.
Did I miss anything?
No. And that's a very precise look at it. And that's what we wanted to give you guys. Just a real quick look. What does this look like? What are the different phases? Now, if we just said, okay, we're done, you probably wouldn't get it. So you have to do something with that to understand that. And so what I'm going to show you real quick before we go is what we'd like to do tonight for tomorrow. Just trying to find it. There it is. So in Noodle, you'll find a link to this document. And this document is called the onion root tip activity. And so you'll notice at the very top, it tells you how to rename it. We'd like you to rename it right. And then it has a link. And if you go to this link, it's at the University of Arizona. I'm going to click on it once. You'll get to a page that looks like this. And so they're showing us down here at the bottom. Here's what kind of mitosis looks like. The only problem with it doesn't sit in interphase for a long time. They're just kind of showing us the steps of mitosis. They're showing you up here what an actual onion root tip cell would look like or a bunch of cells. Like they took a cross section of an onion root tip, put it on a microscope, and we're seeing a bunch of cells. What you're going to do in this activity is identify a bunch of those. So if you come down and hit next, it kind of walks you through. It gives you a little bit of background, re-explains, shows you a picture. Make sure you look at that. And then you get into this place where it wants you to make a chart. Well, if you look at the bottom, we've made the chart for you. So you can fill that chart out. And then you hit next. And it gives you a cell. And you have to look at the cell, and then you have to pick where it goes. And if I look at the cell, I see chromosomes right in the middle. And that might be hard to see on the YouTube video. But I see the chromosomes lined up in the middle. So I'm going to go, hey, that looks like metaphase. And it says, hey, you're right. And then it gives me another cell. And I think it gives you about 30 cells that you're going to actually go through and identify. This one I see like what looks like maybe a nucleolus. I'm thinking that's interphase. Yeah. Now, I'm going to give you some help right now. Just something to think about. Which one of these columns in the chat, which one of these columns do you think will have the most cells in it? Will interphase, prophase, metaphase, anaphase, or telophase have the most cells? If we take a random sampling of cells from an onion root tip, and we use the tip of an onion because it grows really, really fast. Roots grow really fast, so they're always multiplying. Cells are always multiplying because how do we grow? If you haven't figured out how we grow, an organism grows, this is how we grow. We make more cells. So which one do we think will have more?
And those of you that are saying you don't see it, relax. Pay attention to what Mr. Suter is saying. And then when you refresh your Moodle screens when you're done, it'll be there.
In other words, you forgot to open it up.
No, I didn't. Moodle just must have been delayed. Relax.
All right, so what do we got? Which one of these columns, interphase, prophase, metaphase, anaphase, or telophase, is going to have the most cells in it? And why? And we're done if you answer. We're pretty much done if you answer. So let's go. Interphase, 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 interphase. Why? Why? You're right. Congratulations. You're thinking. Love it. I love it. Anybody got a why?
Hello.
Wait, one more second. One Mississippi. Lots of interfaces. Yes, interface. Why? Type it in the chat.
Why?
If everybody's getting it right, you obviously know. So tell me.
And don't say because we said so.
Because there is only one cell during mitosis. No. Not even with the grammar correction.
Think about what mitosis is for a cell. Think about how that might relate to you and what that is, what Mr. Suter said it's like for you in your life, the cycle of your life, the cycle of any organism's life.
Okay. Why would we find more cells in interphase in a root tip than any other phase?
Like the cell cycle is like the cell's life. Why does it spend most of its life in interphase? Try and hear. Anything?
Yeah, I'm just patiently waiting. Yeah, interphase is longer than the mitosis portion. Perfect. Right. Cells spend most of their time in interphase. That's where they grow, develop, and do the things they do. So you're going to find more interphase cells. So if you're feeling like, oh man, every time I click on it, it's interphase, that makes sense because most of the cells should be there. Yes, they spend most of their time growing, not reproducing. Yes, good. All right, so just jumping back to that picture one more time. In the beginning, you're just going to give us a brief description of what's happening in each one. There's 4 cells, 5 cells down here. You're going to grab these and drag them up to the right place. That is not the right place. So I'll take it back out. So really, brief description, drag them, fill that thing out. This is not going to take you much more than probably, I'm going to guess about 8 minutes and 47 seconds to do this. So with us stopping at 15 minutes and 8 minutes, I think we're still in that kind of 20 to 30 minute range, hopefully. We probably tomorrow will talk about this. Don't forget that tomorrow we have to submit our grades. Cell Cycle is going to be on the grade because we took the time to go over it yesterday. We think it should be done.
Correct.
So everything up through Cell Cycle will be part of your midterm progress reports. They will be submitted tomorrow, probably about between 8 and 10:30. So get your stuff done before then if you want it to be on the midterm progress report. Tomorrow, I think we're going to go over this onion root tip activity and talk about that and talk a little bit more about mitosis. And we miss you. We'll see you later, I think. Is there anything else, Mrs. Smith?
Nope, it's just craziness in my house, so I got to go.
Crazy. All right. As always, wash your hands. Stay safe. We love you. Avoid Jello.